Hello everyone, welcome to the Google Cloud Meetup number 8. I give you a short intro over the agenda. We start with my intro now, and then we have Tobias Kaymak here in the office. He will talk about why Ricardo chose Bigtable to complete BigQuery. And afterwards we'll have Sebastian Nickel from 9 Internet Solutions also here in the office. He talk about handling Kubernetes secrets, state of the union. And then at the end we have a quiz by Google. It's moderated by Silvana of Google. And we have now the next iteration of the game, so it will be not in the chat, so there will be a nice game, Kahoot. The links will be shown later if it starts. And then this is real time. And it's not only relevant that you choose the right answer of the multiple choice, it's also relevant how fast you give the answer. And then we'll have short closing. And all sessions are recorded. You can also use the replay already of the live stream here, exactly. And the next events are not yet fixed, but we'll do a tech talk in around April and May, as soon as the sessions are fixed. And then the next Google Cloud Meetup, number 9. How could I write that wrong? As 9 Internet Solutions, write an 8 instead of a 9, is in June 2021. If you have any talks or interesting topics to talk about, please approach me. And then we do the pizza game at the end. That was it. So thank you. I'm handing over to Tobias now.
Can you hear me? Yes, awesome. Thank you very much for this nice introduction. Actually, my talk is a bit around the problem you might face when you run out of space, or when you ever had the problem that your hard disk is full, or you have an MP3 player, you know, back in the 90s or 2000s when you had an MP3 player and you were like, yeah, I want to add this song, but actually, oh no, I don't have capacity left. And I think every database administrator knows the situation when your MySQL cluster, or even if you don't have a cluster, your hard disk runs full, and you are faced with the situation that you need more space. And this brings me to the title of my talk, which is why Ricardo, the company I work for, choose Bigtable to complement BigQuery. Let me tell you a bit about Ricardo if you don't know it. It's a web auctioning site that is online since almost 20 years. So it was founded in 1999, and it's giving secondhand a new home. So 2/3 of its inventory is actually secondhand stuff, and 1/3 is around new stuff. And you can get stuff via an auction or a fixed price offer. As you can see here, it's various things. Right now, of course, my main interest is bicycles, so that's why you see a lot of bicycles that are recommended to me. Again, my name is Tobias Kaymak, and I work in the data intelligence team at Ricardo. So that means I'm responsible as a data engineer for ensuring that everything that happens on the platform can be analyzed and can be basically made into something actionable by analysts and other business leaders. That brings me to the setup. So how does Ricardo's current data processing setup looks like? So Ricardo moved to GCP or to the cloud fully in 2019. And with that, we got a bunch of new technologies. So some of them might be familiar to you if you have been around the GCP universe. For example, Google BigQuery, you might already know. It's a cloud data warehouse. It speaks SQL, so you can basically say, I know SQL, so I know how to use BigQuery because it consists of tables that are then just created inside of different data sets. And as soon as you have these tables, you can start analyzing your data. It can range from terabytes to petabytes. And you don't need to manage any servers or infrastructure to actually benefit from the data warehouse. How do we get the data from our production systems into BigQuery? Well, we have Kafka, which you might know is a message queue. And all the teams are sending around 39 different Kafka topics towards our Flink cluster, which is a stream processing framework that is executing Apache Beam pipelines that are basically doing only one job. They are reading the Kafka topic in a meaningful way, transforming this, and then inserting that into BigQuery so that we can analyze the thing. Apache Beam is not the main topic of this talk, but you can think about it as a unified programming model to actually do batch and stream processing in one go. So you don't need to basically write different pipelines for different use cases. You have one framework that can deal with both use cases so that you can save time while developing. That brings me to my problem. And my problem, again, is about data or how to make sense out of data. And if you have ever been in the SQL world, you might know the following query. So when you just want to join two different tables together, in our case, it is articles and assets. And articles are basically the articles that are online on our platform, and assets are the descriptions of these articles that can be in German, in French, or in Italian, which are the main languages of our platform. And these are stored for historical reasons in different tables. You might ask yourself why, and then I can answer you. Ricardo is from 1999, so there are some decisions made back then that have been just, set into stone for now and are hard to change. So we have to live with it in the DI team. So as you can see here, again, if you want to make sense out of an article that was online on the platform for a specific amount of time, at a specific point in time, you need to join in the assets table because people, of course, can upgrade or update the description of an article. So if you were selling something like a motorcycle and then you think about, I forgot to mention that the right handle has some problem, I'm just going to update the description. That actually is reflected then in the assets table. And a simple join here is a select star. Of course, select star is something you should avoid when running on BigQuery because it's a columnar data store, but for the simplicity of the example, we just keep it like this. And if you then join articles and assets together, you might join them on the article ID in this case. So that's basically a very simple thing to then combine both tables together. That's a batch use case. And the standard use case, again, you might face when the data is already in BigQuery. The main concept I want to bring across is that a stream for us is just a table in motion, and a table is a stream at rest. So that means there's a one-to-one mapping between a table and a stream in Kafka. So that means that a table has a schema and a stream should also have a schema to make sense out of it. That also means that if you can join two tables, you should also be able to join two streams together, right? And as you might know, in BigQuery, you pay for the amount of bytes you scan. That means that the less you scan, the more money you save, or the less money you pay. And since an article can be online on the platform for quite some time, as you know, we are quite old, it means that for some articles, you might have to scan the whole assets table, which is in fact quite expensive, or can be quite expensive. So it might be wiser in our diagram to go to the beginning and join the streams together. So not joining the tables, but the streams in Kafka in front of BigQuery to already make sense out of the data before we have to analyze it. But the problem here is, what if both streams of articles and assets are huge and endless? So in the standard streaming example, you will find a customers table, for example, and an orders table. And you say, well, customer is reasonably small, so we can keep this around, and then we're going to consume all the orders, and we're going to join in the customers. Well, that doesn't work if none of those two fits in memory. In our case, it's not possible to fit them in memory. Now you might argue, well, you could just spin up 2,500 VMs and they would fit in memory, but the problem is also that it's a cost-sensitive matter, and you always have to consume then the streams from the very beginning, meaning that Kafka needs to have the data around forever. And usually our stream processing is made or built upon the fact that the stream is only keeping 14 days of history. So that means that this is not working for us. Additionally, for your mental model of databases, BigQuery behaves like a truck. So BigQuery is very good in moving a huge amount of data reasonably fast, so in seconds up to minutes, so terabytes to petabytes up to minutes, from A to B. But what we are looking for is a Porsche. So we want something, when we want to enrich the stream of articles with the assets, we want to find one key, so the article ID, in the other stream and want to put it in. So I use the Porsche Taycan here, not because I'm a fan of it, but just I looked up the comparison right now. I think it's faster than the Tesla, so it could also be a Tesla. So if you like a Tesla, you can just imagine here a Tesla. I just want to use the electric car for environmental reasons. So what we are looking for, to come back to my picture, or is basically in the side of our stream processing, we want to look up when we are consuming the article stream. Each time we have an article, we want to look up the asset history for this article, and when an asset comes in, we want to also update the store, this Taycan-like store, or this very fast key value lookup store. What does it mean? Well, first, we need to ensure that assets are always processed in front of articles, so that we time shift them maybe a bit by 5 minutes, so we can make sure that if the clock time is right now 6 o'clock, that 5 minutes before 6 o'clock we shift the assets back, so we can always make sure the asset will be processed first. If there is, for example, somebody posting a new article online, and there's some thunderstorm, and maybe the asset receives us before the article, so that we are sure we can update the key value store first with the 2. And then we get all the historical information plus the stuff we might just have been written. And we're going to join it into our pipeline and write it out to BigQuery as a joint table, basically. So the output table will look almost exactly like if we have joined 2 tables, but we did it in the stream processing way and writing it in the stream processing way. So then we were thinking about, okay, we know what we need. So we have a description of the car we want. So now let's look at the market and see what we can get. And we looked at different technologies. The first thing that we tried was, for example, Apache Cassandra, which is a column-oriented NoSQL store, you could say, that actually fulfills a lot of, or ticks a lot of boxes here, and we tried that. It worked, so the good news is it works. The not so nice news for us was basically we have 2 data engineers, so me and my colleague Fabian, who work in the DI team, and we don't have support from SRE. So we are completely self-dependent. So that means that if I want to go on vacation and we build something and it crashes, then either I have to fix it or he has to fix it. So what we are looking for is something that is basically managed. And we know with BigQuery that it's actually never failing most of the time. So that means that unless Google has a complete data center outage maybe in Europe, that might be a reason, but that could also happen when we have something hosted in a data center like ODA OHV cloud in France, which we luckily didn't host in because it burned down, as you know. So that could also happen when you host there. So that means that we're looking for technology that suits us. And this next thing that we tried was Bigtable. And Bigtable is the same kind of thing from a management point of view. It's a bit like BigQuery, because you have you have some knobs to tune, but actually it's really it's the NoSQL key value store that grows almost indefinitely, and it's something you can trust and build on, and it's almost completely managed for you. But I come to that in a moment, what you can basically, or what you have to deal with. But to fit it into a landscape for you, if you know some of these services already. So in the DI team, as I said, we have batch and stream processing things that are either sourced from Google Cloud Storage, which is something like Amazon S3 if you don't know it. It's basically a huge pool of files, and if we need to import something that has been produced in a batch process, we are getting it from Google Cloud Storage. If we have something that comes in as a stream process, we are getting it from Kafka. And then we are going to process it with Apache Beam. Apache Beam can be executed on our Flink cluster, as mentioned in the beginning, or we can also execute these pipelines in the cloud at the Google Cloud Data Flow, which is a data processing service by Google. And now to the interesting stuff. So as I said, BigQuery is columnar SQL, you know, your standard data warehouse that speaks SQL. And Cloud Bigtable is column oriented, so it has a schema, NoSQL. So it works by having just one primary key, and the lookup of this primary key is very, very fast. How fast? Well, it goes down to milliseconds, so it's really fast, and it also scales very, very, very well. The last thing, of course, here is what we're going to do with this kind of stuff. So we either process it further. So if we have it in BigQuery, we might process it further to send it to some third party. Or we are processing it from Bigtable because we're reading history for an asset. Again, or we simply analyze it in Tableau, which is then displayed to business users and other things, or other people in the company that want to know what the company is doing. And we also source from Bigtable and BigQuery more intelligent stuff. So that can be going into the direction of AI platform, or things like Cloud Vision API. So to sum up this slide, it looks very complicated, I know. I just wanted to tell you that if you know some of these services, the new thing or the new kid on the block is Cloud Bigtable for us, because that's the missing part that we were looking for. Something that is like Redis, so it's a key value store, kind of, with a schema, so it's not as simple as Redis, and it is managed, and we don't have to worry about sizes or disk space. And now, as I already warmed you up a lot about how easy it is to operate it, actually the only knob you can tune when you set up a Bigtable cluster, and also after you've set up a Bigtable cluster, is this value. So you can only say, I want to edit this cluster. I'm going to say I want to have not one node, I want to have 3 nodes, I want to have 10 nodes. And this is scalability. So with no maintenance and basically nothing you have to worry about. So nothing to deploy inside of Kubernetes, nothing to worry about to manually configure, especially compared to Cassandra. So in Cassandra, you have the Cass operator that lets you deploy a Cassandra cluster, for example, in Kubernetes. There you have to then think about, okay, what happens when my provision storage is actually outgrown? How do I scale that then? And this is kind of stuff that you don't have to worry about here, because your storage grows linear also with the number of nodes. So each node can hold a certain capacity, and I come to that in a moment. But that's what I want you to remember. There's only this one knob, like a volume on a stereo, that you know. Like if you want to make it louder, you just turn it up. If you want to make it quieter, you just turn it down. Since I mentioned OHV, I hope I pronounced it correctly. So The next thing that comes to mind is, okay, what about disaster recovery? Well, since 2019, there's a blog post online on the GCP blog how you can easily create replicated clusters in distributed data centers of GCP. So in the unlikely case of burning down buildings, you can have automatic failovers to others. And this is also happen transparently. This does also happen transparently behind the scenes for you. So, speaking of disaster recovery, the next question is, okay, but how easy is it to create a backup or replay a backup? So it is easy like this. You can create a schedule for your tables in Bigtable. They are basically then, so the snapshots of these tables are retained for up to 30 days. So you can, for example, have a snapshot every minute or every day in our case. And if you need to replay this backup, it lets you do that into another newly created table and asks you what this name should be. And this is super awesome because if you have ever played around with ZFS or a file system that lets you actually restore snapshots onto other pools, or it's super awesome because most of the time you don't want to actually roll back everything. Most of the time, or 80% of the time, you know exactly, I need this because we just deleted this and I just need this. So it lets you then create this table at this point in time with a different name. You can go there, fetch these records, insert them, and you're done. And your downtime is basically 0 because you didn't even need to stop the running table. I already said scalability is as easy as turning one knob. And to show you what I mean with that is, this is the inserting process. So basically the job that we run on Cloud Data Flow to insert the history for the assets from our BigQuery table that we had already, the 20 years of history, or almost 20 years, into our Bigtable table. So basically pre-filling our Bigtable cluster. And there you can see, so I said 30 nodes, and each node is guaranteeing you 10,000 requests per second. And here you can see nicely that we could insert 300,000 elements per second. And after, I think, 1 hour, I was done. And this is also giving you peace of mind, of course, because if you know that you can disaster recover the complete history in the playback in 1 hour, that's super nice, because then you're starting to experiment. You're thinking about, well, we did a mistake here, we should have designed it differently. And you end up in these situations. And most of the time you're saying, yeah, but now it's too complicated to change, so we're just going to keep it. In this situation, you can just say, oh, whatever, we're just going to change it because we found out it's better now, so we fix it. And if you don't take my word for it, this is my colleague writing to me in Slack. After I set up the cluster and set up the first use case, we had another use case with Zendesk tickets, where we wanted to link Zendesk tickets with customer information. Another use case of, we want to do a point query. So we want to fetch information for this ID and this ID only. And this is where BigQuery is not the best one, because BigQuery can analyze huge data sets. So basically over a set of data, but here you want to fetch a particular point. Again, this is a Porsche example where you're just driving one person. And he was basically also launching a pipeline not in Java, which I was using for the Beam SDK, but in Python. Then inserting the history into Bigtable. And he was also using the emulator. What is the emulator? We will come to that in a couple of minutes, because you might be interested in, okay, how can I give this whole thing a spin? But let me first show you what I said before about the ease of pushing data around. So if you want to, again, if you want to read something from BigQuery and you want to push it into Bigtable, the fastest thing you can use is Cloud Data Flow, a service by Google that is spinning up machines behind the scenes for you, executing your pipeline, and then inserting this into Bigtable here. And it scales linearly together with the Bigtable node. So for example, we had 30 machines executing this code, spin up by the Dataflow service. We spun up or we scaled the Bigtable cluster to 30 nodes. And then this was executing, giving you this nice graph of saying how much or how far it got done. And after it's done, basically Dataflow is shutting down and you can scale down the Bigtable nodes. I had a quick chat with the product manager of Bigtable after some discussions with our GCP representatives, and he told me that maybe even the scaling will maybe in the future will be more automatic. But that's, as I said, this is the only knob you can right now tune or need to tune. But again, it's just one knob, so I don't. It's not a huge issue to do that. And again, this kind of pipeline you can express right now in Python, Java, and Go, which is basically the data flow or the Beam SDK languages. But of course, for Bigtable itself, there are client libraries in any language you can think of. So JavaScript, Node.js, C# and others. So if you want to program against Bigtable directly, all the libraries are already available. Now to my main caveat. So to make the whole system very fast, you need to think about your schema design, because you are, with your schema, as I said, you only have one primary key. So you need to be sure that the primary key has two very important functions in this case. It needs to make sure that your data is distributed evenly when you're writing the data, and it should be enough to fetch as little data as possible. So, for example, I give you an example. When you start out with using Bigtable, you might use your customer table. Your customer ID might be a number that is going from 0 and then upper, like a counter in a relational database system. The problem with that is that if you have 3 Bigtable nodes, and they go from, let's say, for example, your indices or the Bigtable ring goes from 0 to 100. Then the first node of Bigtable will be responsible for everything that starts from 0 with 33, the next one from 34 to 66, and the next one from 64 to 100. So now if you start inserting into Bigtable with a lot of pressure, most of your customers will go atomically, or not atomically, but increasingly from 0, 1, 12, everything will hit the same node in Bigtable. So we will have a hot node basically. The nice thing with Bigtable is that you have this super awesome web interface that actually gives you an idea of at what point in time how hot was your row key. So if this is actually evenly light up, even bright, then you have a very nice row key. If you did a mistake like I did in the beginning, you have only a tiny fraction here, very, very hot, and that means actually that your row key is not evenly. So, of course, we are in Switzerland, so it's not like super huge mega data, but still we have 4 million people on our platform, so it's something. So you want to make sure that this is not sequential, and to avoid these hotspots, basically. And the last big enlightenment I had was basically that tables are 3D. That took me, I think I read a blog post, and that was actually like, this changed everything, because before I was like, hey, how can I design my row key and so on. Any particular value in Bigtable is identified by its row key, including the column family and the cell timestamp. What is a column family? Not really important for today's talk, because that actually lets you group different columns in a table again to fetch only a certain column family. So forget about this, but just remember you have the row key, you have the column key, so like a normal table, but also timestamp. That means that your cell values can have history. So you can fetch a value for an article, in our example, an asset, a description for an article on the 1st of January or on the 2nd of May, because that's basically the third dimension that comes into play here. So now the last question I have in mind actually that comes up when you think about this pipeline. So again, you're reading from Kafka. You have assets always processed first, because you have this temporal ordering. You write out the asset that you receive, you fetch all the assets, and then you join in the articles, because you actually looked up for an article all the assets, so by article ID. And why does this work? Well, Bigtable has read your writes consistency. So if you have a writing thread, and you are making sure that each thread is responsible in your application for handling so the same custom ID is always handled by the same thread, for example, so it's not spread out, then you have the guarantee that you read your own writes. And this way we can make sure that if we write out something and then later 1 millisecond later we fetch everything for this article ID, then we know that our own writes will be inside of this fetch, because otherwise you would not have this. So this is also very important. So read your writes consistency saves us in this scenario. So what I want you to take away from my talk is that where BigQuery allows you to quickly analyze terabytes to petabytes of data with SQL, basically, Bigtable lets you do NoSQL key value lookups in milliseconds. And these key value setups, so the value can be a fully fledged schema-based table. And Bigtable is very easy to operate. It requires basically no maintenance, no software upgrades, and no security fixes. There's just one knob to tune, so scaling is very easy. The only thing that you can scale is the number of instances, and that's it. And with that, I want to say thank you for your attention. And of course, I have the hiring slide here. So we are looking for collaborative co-workers. You can check out our jobs on our jobs page, and we are looking especially for Valbon in our French office, but also in Zug there are some positions open, so go and check them out. Here are my sources. So because all the images I took, these nice ones, of course, I have to give credit to the people that actually took them. And I'm open for any first questions that might have come up so far, because maybe I've spoken too fast. Is there anything from the internet? Are confused or maybe want to know something?
Yes, there's a question from Pierre. He wants to know which connector did you use from Beam-Flink to Bigtable?
So Apache Beam has the Bigtable I/O. That we use Java, the Java SDK of Beam, and Beam has the Bigtable I/O built in. The good thing is that Beam, or Apache Beam, is the open source data flow SDK, so all the Google services are more or less covered very well, and so all the connectors there are mostly feature complete. Does this answer the question, or?
He may ask again in the chat if it doesn't. And he wanted to know another thing. At the end of the talk, he asked Java or Python. I don't know if you can relate that to the exact.
Yes. So we use Bigtable with Python libraries for the service with Zendesk for reading and writing. We also have Beam pipelines in Python to fill Bigtable. And we use Java pipelines to fill Bigtable and connect to it. And we use Java for BigQuery. So Java and Python is both. So data engineering, I would say 80% Java. And for everything else, it's more 80% Python. So if you move out of data engineering, where it's just Kafka to BigQuery, for example, then it might go more into the Python direction. But in our team, it's Python is the main language as soon as data engineers talk to analysts and other people. So that's why we have both.
Okay, and then he wanted to know again, so no Python connector yet.
For Bigtable, there should be one.
Okay.
I would say, so for Beam, I'm 99% certain that there is a connector for Python. Actually, I'm 99.9%, but I can check after the talk. For normal client libraries, I can show you in a moment that there is a connector. I prepared actually, if there is not an urgent question right now, I prepared this additional slide because most people then are interested in, well, BigQuery I pay per volume, so it's like pay per use, like your phone when you have a prepaid card, which is actually not prepaid, but you get the idea. And with Bigtable, you have like real costs. And but the good thing is, compared to Cassandra, where you need to start with at least 3 nodes, that was also my wrong assumption in the beginning. With Bigtable, you don't need 3 nodes. You can live with only 1 node. Of course, it means that sometimes it could happen that the node becomes unavailable. It never happened to us, but in our data processing and in our pipelines, we have retries. So even when the node becomes 1 second unavailable, we can deal with that. If we are not able to deal with that, we could spin it up to 2 nodes. I'm just making up here the example because we're running our stuff in Belgium, so Belgium is a bit more expensive. You can see that in Belgium it's $468 per node. That's the linear cost if you scale with 1 or 2 or 3 or 4 or 5 nodes. You get, you can assign up to 2.5 terabytes of SSD storage for the node and 7.5 terabytes of storage if it's an HDD node. So that's basically what you maximally can put on one node. If you add another node, that grows linearly again. Each node, as I already said, can handle up to 10, can guarantee 10,000 requests per second. So that gives you peace of mind when you're really planning this kind of stuff. You can see here, which is very tiny, I'm sorry, but this is actually telling you, so I told you in the beginning we have huge data, and here it's saying that we have only 269 gigabytes stored. And that is because it's compressed. So the nice thing with Bigtable compared to BigQuery is, for example, when you take the same table one-to-one from BigQuery and you push it into Bigtable, because Bigtable has also data types and so on. If you have string types, for example, descriptions of articles are, of course, huge strings. The compression, when it kicks in, is really nice and actually can compress it a lot. So this raw data here was around, I think, 600 something, and this is now 269 gigabytes. So compared to the table in BigQuery, this is really not as much as I also had anticipated, because when I did the back of the envelope calculation, I looked at how much storage do we use in BigQuery. Okay, around about this I should plan for Bigtable, but no, it's actually less because you get compression, which is super nice. And I have another bonus slide. So because it may be a bit fast when I talked about the join between articles and assets in Kafka that went into this pipeline. The reason why it works is because the framework, or the Beam framework, actually gives you guarantees as a developer. And when you use a windowing function in Beam and you have these timestamps attached, you can make sure that all events that are within a certain time frame, the stream of events is sliced up, and all these events are processed together. So if you slice up the time by 1 hour, out of order events are automatically ordered, and you can make sure that all events that happen between 4 o'clock and 5 o'clock are all within this window. And then if we rewind the asset by 5 minutes, we can make sure that if we then send them down to this enrich function, which first inserts all assets into Bigtable and then fetches all assets for a certain article ID, that this is actually including everything, as long as our pipeline is not 5 minutes behind. But this is actually to prove you that this real magic, or this that this is actually working, is due to the fact that the Beam framework gives you this windowing transform and lets you write it like this. And now I also prepared a quick demo. I hope it will work. So because there was a question from the audience about connectors. Again, for Beam Python, Bigtable should be available now, but I will I stand corrected if this is not the case. I just have to quickly fix my display because I cannot see it. But what I want to show you now is basically the I know why. What I want to show you now is that with the standard library that comes with the Python SDK from Bigtable, you can already, with a few lines of code, start doing things. And of course, you saw the costs, so most of the people will be scared and say, yeah, but how can I start coding with something? I mean, before I get something out of the door, a prototype that I can show my management to actually justify these costs, I already have spent so much money, I will never get the approval, because sometimes you need to get the working prototype first before you get the approval to do the prototype, sometimes. So the good thing is that the gcloud SDK comes with the Bigtable emulator that lets you write in your favorite language with the client libraries against a Bigtable emulated thing on your local machine. And that is also working for testing and other things. So if you use CI, you can use that to actually test that your application is doing the right stuff. So here I have on my screen, is it big enough? Yeah, okay. So the top of my screen here is the Cloud Bigtable emulator. I've executed this with this command locally. And below that, I have just a normal command line. So here I have the CBT command line utility that can connect to my Bigtable local cluster. And I've created this Meetup table. So right now, when I read this table, it's empty. And read is something you should never run on a production cluster because it actually reads everything. So if you have a huge table, it will just stream that back to your machine. And if you are on a data plan and you use UMTS, you are screwed. So this is actually the code. This is all that needed to actually insert something into Bigtable. So this is just the function to get the timestamp in Python. The column family, there's again, if you don't want to use column families to group your data, the default is always use CF1 as a column family name, because that's the default in all the libraries I've seen. So not really interesting. Here's a row key. In my example here, I have 431, so I reversed the key already for you. And there's a direct row transform. And this direct row transform basically writes the row out directly. You can also chain up your transforms to make it do everything at once. So if you want to make sure that many transforms, because there's no transactional concept, right? And here we have the function. So we set the username of this column family for this timestamp to Alice, and then we just run the commit. And that's everything you need to do to write out the value. So I'm doing this now. It has been executed, and now if I read the Meetup table, I can see that here, this is how actually it's displayed. If you would also connect to a production cluster, you would see the row key first, you would see the CF1 is a column family, and then you would see all the columns that have been defined, and then their values. And here we see the timestamp. And to give you the 3D concept again, if I just execute the same again, because then it will use the current timestamp, we see we have 2 times the value, and here there's a difference between the 2 timestamps. So if this username, for example, would have changed over time and it would have written Bob, then I could be then retrieving this this key and this row key and this column for this specific timestamp in a filtering for this client. Yeah, and this actually is everything you need to know to get started with Bigtable. So I can just encourage you to try out the Bigtable emulator on your local machine, so you don't need to spin up a whole cluster. And you can start building applications with it. And if you have any more questions, I don't have any more slides or demos for you. So now you are free if you have any more questions for me regarding my talk. Thanks.
Thank you very much, Tobias. We have no more questions left, so the 2 people are talking to each other in the chat regarding this link where this connector is. So
this is the best audience that is actually helping each other.
Okay, also thank you very much for your talk. So, and we'll hand over now to Nick. Give us 2 or 3 minutes to connect his notebook, and then we'll be right back with Sebastian Nickel. So, and I'm looking forward to the game afterwards. I'm very excited who will win the game and how many participants will join the game. And be aware that it's also important how fast you answer the questions, and not only that you choose the right questions. Thank you, Dan, for the thank you. So we're about to switch now to Nick. Okay, looks good. So
okay. Okay, so yeah, my talk is not as complex as Tobias' talk, actually. I'm just talking about secrets handling in Kubernetes. Yeah, it's about secrets in Kubernetes. Who am I? I'm a platform engineer at 9. My name is Sebastian Nickel, aka Nick. I'm interested in containers, Kubernetes, Golang, all that new fancy stuff, basically, but also in old road bikes. I guess that connects me a bit to you, I'd say. Yeah, what is this about? Well, the whole thing, as I already said, it's about secrets. Your Kubernetes workloads, so your pods, for example, they might just need access to secrets, like passwords, certificates, or whatever. And obviously, we can store those secrets in a Kubernetes secret. I mean, it has a specific type or kind for that. And then we can mount it into the pod. But the talk is more about how should we actually manage those secrets? How should they be created? And also the content be managed. And that actually depends on the use case. So the most obvious is just add the secret manually via kubectl. I mean, everybody of us, or at least everybody who worked with Kubernetes so far has done that. You take your secret, you write into a file, you use kubectl, and then you fire up, or you basically push it to the cluster. The cool thing is, I mean, that's good for one-off tasks, and it's very fast done. But there's no version control for it. It's not really automated. I mean, you could argue now my kubectl command is in the script, but it's not really, I'd say, automated, and it can be changed by anybody with access, actually. So if it would be like written all the time by an instance, which is external, like no human, then I think that would be better. So yeah, it's fast, but maybe not the best for production use cases. If you want more control, you can use GitOps techniques, right? So for example, Argo CD, which is that nice tool which reads a configuration from a Git repository and just pushes that configuration continuously to your Kubernetes cluster. You change your stuff in Kubernetes, for example, in your Git repo. You do a merge request that gets accepted, you merge it, and then Argo CD will take that up and push it to your cluster. Everything is automated, everything is fine, you have a history, cool. The thing with that is actually your secret might be just plain text, right, a password. So plain text or base64 encoded secrets, should we put them into Git? No, we shouldn't, because Git was actually not designed to be a secret store, right? So because if your Git repo ever gets like taken up by some not really kind person, they will just be able to read your secrets. That's just an example for a Kubernetes secret. You know, all the stuff is basically base64 encoded there, and base64 encoding is not really encrypting stuff. Yeah, so sealed secrets to the rescue. I mean, there are actually other projects which take the same approach, but I decided to go with sealed secrets because, yeah, we just chose that project to be the default or one of the default applications we deploy in our managed GKE solution. Yeah, the project is from Bitnami. The sealed secrets project consists of controller. That's basically, that reads an encrypted sealed secret. So the sealed secret is a specific kind, a CRD, coming from the project. It reads that custom resource and basically turns that into a Kubernetes secret. So what it will do, in the end, you will have your Kubernetes secret, but in Git, you will have encrypted content. It uses public and private key encryption. We encrypt with the public part, and the controller knows about the private part and can so decrypt the secret. You have a CLI application called kubectl, which handles the encryption part. Yeah, but we, as some people are not really CLI aware or friendly, we have a UI basically. I just hope that works in our cluster for every project. So you go there, you type some stuff there, right? Test password, and it will just spit out the sealed secret. So that's the sealed secret, and then you just put that and into your Git. Copy it and put it into your Git, and everything should be fine. So that's cool. Yeah, I like it. But what if more automation is actually needed? The thing is, because yeah, if you want to automate things, writing that new configuration to Git is not really cool because Git is not really an API, right? I mean, you need to deal with merge conflicts or stuff like that. So that shouldn't be the ideal solution. So in my example here, we have basically 3 teams. We have team A, which is just developing a Kubernetes application. We have team B, which is dealing with creation of external resources like databases, Elasticsearch clusters, I don't know, Redis, whatever you can think of, right? And then there's the other team which runs an application just on a VM and not on Kubernetes. So, I mean, they might just need to exchange secrets, and there is a piece in the middle actually, which we'll reveal in a second, and I think that just shouldn't be Git, right? We need some communication between the teams for the secrets. And yeah, obvious. I mean, there are cloud solutions as well. There's, for example, the GCP Secrets Manager, but the open source basically solution which almost everybody takes is Vault. Vault from HashiCorp, which is a secrets manager basically. It can be deployed highly available. Since I don't know which version actually, it can just do it by itself. Before it depended on, for example, a Consul cluster. But now you can just spawn up multiple pods. They will use a Raft consensus algorithm, and then they will be highly available. Yeah, we can there store secrets in a key value fashion at a certain path. So Vault is path-based. For example, you write just a key value store to /credentials/database. And someone else can read it at that path again. And it encrypts at rest. And it supports multiple storage backends. So if you don't want your stuff to be stored in files, you could store it, for example, in Cassandra or in another database or whatever. Yeah, and it also supports multiple secret engines. In the beginning, I didn't really understand what a secret engine is, but if you think more of it, then like you want to create actually a secret. You say to Vault, I want to have a new secret for that and that use case. And one use case actually is creation of temporary MySQL credentials, for example. So Vault has a connection to your database. You ask Vault for a credentials pair. Vault will go to the database, create that credentials pair, and keep a lease of it, basically. So it knows when to delete the pair again. Yeah, but we will see that later. And it also supports policies. So not every application which talks to Vault has access to every secret. I guess that's one of the main features it actually has. And those policies are path-based. So you can say, okay, path/credentials/database is only accessible by certain applications. Yeah. So back to the example. Back to the example, right? So the thing here is if my Kubernetes application actually talks Vaultish, so it understands the Vault API, then that's not a big deal. The same for the application running on the VM. If they all talk to Vault, basically, that's cool. And then we don't need anything actually besides that. But sometimes you just have applications which don't know anything about Vault. They just want to read their credentials from a local file, for example. And that's basically, what I want to talk about. We don't have any direct Vault integration, so we actually need a way to get the Vault content into Kubernetes secret where our application can read it from. One way of doing is using the Kubernetes external secrets controller or project. That actually, what I found out yesterday is actually they're currently rewriting it in Go because there are actually 3 companies. They did almost the same, so everybody developed a controller for that. And then they joined forces, and now they want to rewrite it in Go under the URL I pointed last here. So far, I took the current existing project. So you have an external secret resource. It's similar to a sealed secret, I mean, from a CRT standpoint. So you have a custom resource. It supports multiple backends, so it can read the secret from Vault and also from, for example, GCP Secrets Manager. And instead of putting the plain text of your, or an encrypted version of your password or secret into Git, you just specify the path in Vault for your secret in your external secret. Then you create the external secret, the controller will fetch the content from Vault, and then it will create a Kubernetes secret with the real content it fetched from Vault. Yeah. And additionally, it allows for templating the created Kubernetes secret, because if you think of Vault, you have a key value store, but you actually expect, I don't know, some TOML, YAML, or whatever format in your configuration file for your application. Then you can use templates in the external secret CRD, and it will just use the real data from Vault, put it into a template, and then generate your configuration file, for example. Yeah. Okay. So that's the first demo. I actually hope that I can put it here. Okay. Yeah, so I prepared a little kind cluster actually. Oops. Okay. Which should show that. What do we have here? What do I have in my kind cluster? For the example now, I just have a Vault. I have a Vault server there. Deployed. It's just no HA, just a single Vault with in dev mode. So there's also no encryption or whatever, but it's perfect for playing use cases. I have a producer, which is a small Go binary, and that will actually write a secret every 5 seconds to a specific Vault path, a new secret. And for the example for now, I also have the external secrets controller deployed into a namespace, and I have an external secrets consumer, which mimics basically your legacy application, which doesn't have any integration with Vault. It just reads stuff from a predefined directory. Yeah, so that's what I have. I'm already in the right directory. What do we have here? That's the external secrets consumer thing I just talked about. Yeah. That's the external secret, right? The CRD I talked about. I specify the backend type Vault. I'm not sure if that's actually big enough. Okay. Yeah. I give the key value version. Vault supports 2 key value versions. Not really, doesn't really matter for now, but I specified version 1. And I'm just saying, okay, please read the key or the path, basically, credentials producer. That's the secret my producer application writes to. That's the Vault path. And just read the key credentials. They call it property, but in the end, it's just one key of that Vault path. And yeah, and what it will do, it will just create a secret with the name credentials, so with the same name as my external secret, and put the real data in there. I also have the consumer. That's what I also said. It's just a very simple deployment with a small Go app, reading everything what it finds under /config, and that's where I mount the credentials secret at, right? So if I just do a kc apply -f, I have a pod now, my consumer pod, and I also have my credentials secret now, right? That's not the external secret, that's my real Kubernetes secret. And if I do a log of my pod, I can barely see my mouse pointer here. What you just see is that it reads basically every, what did I put in? Every 2 seconds or so. Reads all the contents from /config. It found the file called credentials. So the actual name I configured in the external secret, and it found the content, password, username, admin, and yeah. What you can see here is if I told you that I'm writing actually a different secret. That's very interesting, right? I'm writing a different secret every 5 seconds, but in my pod, that's actually not really changing, right? So I guess we need to have a look into the secret. So YAML credentials, and then we also watch it. I don't know if we can actually see the values here. Yeah, it's the small. Secret credentials minus O YAML. Oh, credentials. Is that right? Okay. Hard for me to write actually. Where is my data? Actually don't see that. There you go. So let's say we have what at the end? LUIN 0 or something like that. Oh, it's not really changing. So maybe my producer doesn't really work. I'm not sure. It worked last time. Because in the secret, it should actually change every 5 seconds. My producer works. It writes a different secret every 5 seconds. So what is it? External secrets. Consumer. Do we have a different thing now? Very strange. I actually wanted to tell you that the secret gets updated every, I think it reads it every 10 seconds, the external secrets controller. But that will not be reflected in my pod. And that's because if you ever mount a config map or a secret into your pod, it will only be updated or refreshed by Kubernetes every 2 minutes. Very interesting that my external secrets controller doesn't update it, although Vault is updated. I don't know. But yeah, you need to keep that in mind. Actually, if you mount something into your pod, you have by default, you have a 2 minutes delay for new values. I don't know if you will ever change credentials that fast, but yeah. Okay. I just need to get that through. That was a demo time already. Yeah. Vault Agent Sidecar Injector. As you have just seen that, yeah, sadly you haven't seen it, that it wasn't updated, but it should. There is another thing which comes directly from Vault, basically, or from HashiCorp. That's the Vault Agent Sidecar Injector. It's a different way of handling the secret because it will also read from Vault, but it will not put all the stuff into a Kubernetes secret. But instead, a sidecar in your pod will be started, which fetches the secret and writes it to a local shared volume, which is of type memory. So it doesn't even go to disk, but it's only in memory. Yeah, and no Kubernetes secret is involved. That's a project coming directly from Vault. Yeah, and I tested it. So I guess that one. Sorry. Did I actually close my shell? Okay. Well done. GCP Meetup. Secret handling. There is the Vault injector thingy. Okay. What do we have here? It's actually, you can already see there is no external secrets YAML because we don't create that resource. We just create a deployment, and all the control basically is done with annotations. Should I just increase that here? We basically have annotations attached to your pod, and you just specify, okay, inject the agent, please, with agent inject true. We specify the path, again, credentials producer. We also need to specify a role. That's basically Vault works with roles. You need to say when you log in or when you get a token, you need to say, I want to assume a specific role, and a policy is basically also bound to a role. So yeah, you need to basically say what you want. But you can't, for example, you can't use every role that's also coming from your configuration. And then we also inject templates. So I think that the configuration is a bit more complex, I'd say, compared to the external secret. Because by default, the Vault agent just reads what you have at credentials producer or at your path, basically. But it will not write it down as a JSON, but as a, I don't know, it looks more like a Golang kind type, basically. So it will write map, you have a map, and then you have a list or whatever, right? So that's why I specified a template here, and that will just do the same thing. It will move everything to JSON and store it at a given path. And that path is actually hard-coded in your Vault agent. You can't change that. All your stuff will always be mounted at Vault secrets, so my consumer will also read from Vault secrets. Okay, let's hope the demigods will be with me this time. Keep going. Is the apply minus F? Well, because I didn't use unexpected args. Did I actually change? No. Not sure actually. What? Did I? Oh, sorry. Yeah, sorry. Okay, thanks. So kubernetes, we go to our Vault consumer namespace. We can see that now the consumer pod is running after I fixed my typo. And now we can already see that we have a sidecar now injected, and now you need to specify the container name for your logs. So I want to have the logs of my consumer pod, consumer, right? And yeah, it also says, okay, you found the file, content credentials, and what you can see now is actually that the content is changing, right? The content of my secret, and it also respects my given TTL of 5 seconds. So here it's actually working. I don't know why it wasn't working in external secrets. Yeah, so that's really cool. Also, you don't have that 2 minutes delay now, right? Because it's actually writing to a file and not to a Kubernetes secret. So yeah, cool thing. It worked for me. I had a bit trouble with the whole templating thing until I got that working, but I think that you just need to get used to that. It's a console template, what they're using. Okay. Actually, like this. Okay. Hello. Okay, so are there any important differences between those kind of approaches, basically? When using the external secrets, the refresh time of the secret in the pod will be lower. I mean, we've seen that. Right, with Vault, actually, you can just read it. And when using external secrets, your secret or credentials will end up in etcd, because you're actually creating a Kubernetes secret, right? So yeah, it needs to, you need to trust basically your Kubernetes provider if they encrypt etcd, because otherwise you can just read it from there. With the Vault provider, I mean, it writes to a memory, right? So it never leaves basically your local host, I'd say. But that's also a downside of the Vault injector, which I also noticed in my test. If your Vault server is down, then your agent can't fetch the secret from Vault during that time, and your pod actually won't start. Yeah, if you think of it, if you have, let's say your Vault runs in Kubernetes, where your workload also runs, then I don't think it's a big deal, because if you either have an etcd running in HA or if you have a Vault running in HA, I don't see any big difference there. But if Vault is running outside and you have a big network path in between, then that actually might be a problem for you. And one downside I noticed is the static mount path when using the Vault injector agent, because it always mounts at /vault/secrets. Yeah, but in the end, actually, just use, I don't know, either of those solutions, and Vault will already give you a high degree of automation, I'd say, and you can also centralize all your secrets in one specific store. That's very cool. And another use case I had, let Vault handle your database credentials. I told you in the beginning about it. The use case is just password rotation for applications. And I pointed it out here in the graph, basically. Your Vault cluster has a connection to your database, and it creates, refreshes and revokes credentials for you, and your Kubernetes application just periodically requests new credentials from from Vault. And if it, for example, doesn't do that anymore, then that's cool because your credentials won't be refreshed and your application won't leave any unnecessary credentials around anymore. And you actually don't have to put specific credentials in any secret, right? You just need to know the Vault path. And that's it, because your application will just read from that path, and in that moment, your Vault cluster or Vault server will create the credentials pair. That's really cool. Demo of this. Forgot about it. MariaDB consumer. So what I have here is just, where is it? A MariaDB, basically, simple database. I created a simple DBMS. I created one database, which is called staging. I have my Vault again, and a MariaDB consumer, which will just ask for credentials, basically. Okay, KC apply f dot. Okay. I have my pods. Pods are still initializing. We can maybe check the consumer YAML. So again, agent inject true, right? I'm reading from databases cred staging. So I mounted the whole database, how you call it, the secrets engine at databases, and the access path to that is creds, and then a role you actually created. So I created a staging role, so all staging applications which need access to that database, they can just request, the staging role, which is different than that role actually. That's a role used for the authentication to Vault, and that's a role used for the whole secrets engine. And yeah, I also wanted to play a bit with the templating more, so I'm just reading it and I'm putting it out as a YAML, basically. Data username and data password. The secrets engine will just create those two fields at the path, username and password. And again, I'm reading, the consumer just reads from /vault secrets. Guess, I just hope, just hope it should be started now. So do KC logs. And I just need the consumer pod container again. And as you can see, basically, what I also did is that that I configured, I think, a 30-second TTL of those credentials and the max TTL of 1 minute, I think. So you can already see here that the credentials are changing now. In the back, your Vault agent will try to further increase the lease time of your credentials up to max TTL. So my max TTL is 60 seconds. And after that, it will just ask for a new credentials pair. And you can see username and password was written by Vault. But it also means your application needs to be aware and reread your credentials, basically, to have a new database connection, or even to reinitialize the database connection. But I think it's something cool. You don't need to have, or you don't need to handle credentials at all. You just need to give proper policies, and you need to know the path from where you need to read the credentials from. That's something which is the Vault agent, but I think it's also possible with the external secret. I just don't know if external secret will respect the TTL of the credentials. That I didn't test, actually. That's already it. I noticed. So, any questions?
So there were no questions so far in the chat. Tobias has a question.
You have to repeat it maybe because I don't have a mic now. But is this also possible with Cloud SQL, or because you have the MariaDB inside your Kubernetes cluster? Is this connection between Vault and the database, Postgres / MariaDB, it doesn't matter where it is, right? So the question
was basically, can I just use the same thing I showed at the last slide with a Cloud SQL instance, so a GCP managed database? Yes, that is possible, because just Vault needs to know a credentials pair with which it can actually connect to your database. There's actually a cool solution, or a cool feature of that. It supports root credentials rotation, which is, I don't know, cool, but also a bit scary because it will rotate your root credentials to the database regularly. Yeah, I mean, yeah, it's secure, I think, because you rotate the credentials, and if someone got knowledge of those credentials, leaves the company, then at least he has or she has basically a limited access of, to the database. But me, as coming more from the admin side, I'd say it's a bit scary. Yeah. Any more questions?
So no more questions. Then I would say thank you very much, Nick, for your talk. And we're handing over to Silvana now. She has still to unmute. Oh, okay, and I'm changing. Wait a second. Okay, now we have Silvana. Let's go.
Hello, everyone. My name is Silvana. I'm a digital native lead for Google Cloud Switzerland, and we will be doing a GCP quiz. Maybe some of you who have been around for longer know them. So if you don't know what you want to eat or what you will be eating for dinner today, this will be your chance to get dinner covered by us and by participating in a Kahoot quiz. So maybe you know them, and if not, don't worry, it's very easy. So basically the only thing what you have to do now is to go in a new tab or in another device to kahoot.it. There you have to enter the game pin, which is here 6950473, and enter also your work email and choose a nickname that other players will see on the screen. Then you're all set for the game. As Tom already mentioned before, it's not only about being correct, but also about being fast. So you have to find a good balance between those two. The questions will be about Google Cloud. Some will be about the topics that we covered before, some about maybe new topics, but they shouldn't be too hard. And yeah, for the top 3 winners, we'll be delivering a pizza to your home. So that's why we'll also need your email so we can contact you and ask you for your address. Your address will be then deleted, of course. So yeah, the conditions to participate in the game would be that you are based in Switzerland, so we are actually able to get it delivered to you, and that you're willing to share your email address with us. So let's have a look if some people already have signed up. Yep, we have some signups. All right, I will start sharing the game screen with you, so you can track with me together who has been signing up so far. And just as a reminder for you, the quiz has some or the YouTube stream has some time lag. So I would recommend, if you're participating in the quiz, to pay attention to your screen only, so to your either to your phone or wherever you're logged into the game, because otherwise you might miss the time if you look at the YouTube stream. So that's my personal recommendation for the ones who are participating in the game. And I will start sharing the game screen. So far we have 10 people. Let's wait for some more to join. Maybe let's give it a few more seconds. As I said, this was a great chance for you to not having to take care of cooking tonight and what's up for dinner, but we'll have it covered for you. Last time we had a few winners, and the feedback that the pizza was great. So, and you can also choose what kind of flavor you want. So we will leave you the choice as well. So we're still having 10 players. I'll say that we slowly start. As I said, look into your kahoot.it screen and not into the YouTube stream. Otherwise, you may you will have a time lag. And as I said, speed is very important, so you may miss some seconds there. All right, let's get it started. The first question is, okay, let's count down. How many Google products have more than 1 billion users? So, countdown is running. 4 correct answers. Very nice. So let's go on to the next question. It's indeed 9 products. Sultan is on the leaderboard. Let's go on to the next question. This game can change really fast. So don't give up if you're right now, if you don't see yourself on the leaderboard now. Let's go on to the next question. What percentage of internet traffic goes through Google's network? So, how much do you think? Keep in mind all our products. Not. Oh, actually, you guessed most of you guessed even more. Interesting. So yeah, it's indeed 25%. 3 of you guessed it correctly. Now we still have Sultan as the leader so far. Let's go on to the next question. What is the #1 reason outside of technology why customers select Google Cloud? So some of you are our customers already, so you may know the answer, which was also important for you and maybe also the main decision driver here. Yeah, most of you guessed it right. Google's innovation culture. Very nice. Let's go on to the next question, or let's see. Sultan is still #1. Very good, Sultan. I think you're on a safe path now. So, who is one of our 100% GCP all-in reference customers? What do you think? Spotify. Yeah, 6 guessed it correctly. Very good. You seem to know us very well. Sultan is still leading, but the other spots are quite interesting. They are changing a lot. So for the next questions, I hope that you paid a lot of attention to Tobias' presentation, because there are some topics that he touched there that we will be addressing in the next question. Which fact about BigQuery is not correct? What do you think? Which one? Oh, very nice. So actually, that's a very common misconception that BigQuery only supports SQL, but apparently most of you know that already, which is very nice that you know us so well. So, Sultan still leading. Very nice. And MKO has been also on the second spot for a while now. So now the deciding question, which fact about Cloud Bigtable is not correct? Still last chance for some of you to get onto the leaderboard and still win a pizza for tonight. So what do you think? Read carefully. Exactly. So clusters can be actually resized with no downtime at all. And most of you guessed correctly. All right, we're done with the quiz. Let's see who won. MKO, third place. Toby, second place. And the winner is Sultan. Very nice. So you shared your email addresses with us. So I will reach out to you now and get the pizzas delivered to your home. Thanks very much for participating.
Thank you very much, Silvana. So, if you have anything more to say, please do, or we leave you in ordering the pizzas, I guess.
Exactly. No, that will be it from my side. Thank you for all of the 10 of you who participated, and my big congratulations to the winners. I will reach out to you right now to take care that you get your pizza at dinner time tonight. Thank you, everyone.
Okay. Bye, Silvana. Okay, thank you very much for joining Google Cloud Meetup, and thank you everyone for joining the game. I'm happy to see your pictures or selfies. If you get the pizza, it would be great to share them. If you have anything to contribute, please let me know for later talks. If you have any feedbacks, please let me know. And if you liked our meetups, please give us a like below, or just subscribe to our channel. That was it from our meetup. Happy to see you next time, and bye.